Hello everyone. Today we are going to analyze this beam using consistent deformation method. In this beam there are two spans, span AB and span BC. There are 2 point loads 10 kN. Both of them act in the center of the spans. Length of AB is 10 meter and length of BC is also 10 meter. In this beam, the number of unknown reactions and moments are 3. There are only vertical reactions RA, RB and RC. The available equilibrium equations are 2. The degree of static indeterminacy will be 3 minus 2, so it will be 1. Let us release RB. You can see that I have released RB so that the continuous beam becomes a simply supported beam. To find the reactions RA and RC, we have to divide the total load by 2. The total load is 10 plus 10, so that it will be 20. When we divide that by 2, we will get 10 kilonewton. Let us keep this point as D and this point as E. We know the formula to find RB minus delta L upon delta. To find these two, we are going to use unit load method. In the unit load method, we have to make sections. In this beam, there are 4 different parts: AD, DB, BE, and EC. So we have to make 4 sections, one in AD, one in DB, one in BE, and one in EC. But we have an advantage. This beam is symmetrical and the loading in this beam is symmetrical. So the moments in AD and CE will be same and the moments in DB and BE will be same. In this case, we can make only 2 sections and we can multiply the moments by 2. So I'm going to only make the sections in AD and DB. You can see that I have made 2 sections. Both of the sections I have made at a distance of x from A. Now let us make a table. In the table, first let us enter the members. Two members are same, AD and CE, and again two members are same, DB and EB. Here the limit is 0 to 5 and here the limit is 5 to 10. We are going to find the moment M from the point A. In this case, we have to follow right hand side rule. Clockwise will be positive and anti-clockwise will be negative. First, let us take the section in AD. Up to the section, we have only the vertical reaction RA. It is acting in the clockwise direction so that it will be positive and the distance is x. 10 into x, it will be 10x. Now let us take the section in DB. Up to the section, we have RA and the concentrated load 10 kilonewton. RA is acting in the clockwise direction so that it will be positive and the distance is x. This load is acting in the anti-clockwise direction so that it will be negative. For this load, we have to take this distance. This distance is x minus 5. After simplifying this, we will get 50. Now we are going to find the moment small m. We need to remove all of the loads from the beam and we have to apply unit load in the point B in the direction of RB. To find RA and RC, we have to divide the unit load by 2. Doing so, we will get 0.5. The unit load is acting upwards, so RA and RC should be acting downwards. Let us find M. Up to both of the sections, RA is acting in the anticlockwise direction so that it will be negative and the distances are x. So it will be minus 0.5x. Using this formula, we can find delta L. We have to be very careful. These two values are for AD and CE, and these two values are for DB and EB. So we have to multiply the integrations with the 2. Using a calculator, we can do the integrations. For delta L, we will get this. Then using this formula, we can find delta. In this equation, we have found both of them. Let us apply them. Negative into negative, it will be positive. We can take this term inversely and then multiply. EI and EI will be eliminated. Finally, for RB, we will get 13.75 kilonewton. Now let us take the real beam. Applying this rule, we can find RA and RC. Since this beam is symmetrical and loading is also symmetrical, RA and RC will be having the same value. So instead of RC, we can apply RA. In this way, for RA and RC, we will get 3.125 kilonewton. Now from the point A, let us take a moment about B and find the moment at B, MB. Let us assume that MB is a hugging moment. RA is acting in the clockwise direction so that it will be positive and the distance is 10. This load is acting in the anticlockwise direction so that it will be negative and the distance is 5. About AB, MB is acting in the clockwise direction so that it will be positive. Finally, for MB, we will get a positive value. That means our assumption is correct. MB is a hugging moment. Using this formula, we can draw the free movement diagram. Using MB, we can draw the end moment diagram. Then we can combine these two diagrams so that we will get the bending moment diagram by superposition method. Here you can see the shear force diagram. Then we can find the moments at various points of the beam. This is the proper bending moment diagram. Now we are going to end this session. Thank you for watching this video.